Right, good day, I'm Mr. Simons. This the lesson we'll be determining concavity or the second derivative, right? I'll give you a brief explanation of what it is, but the concavity we'll do more in detail when we're doing cubic functions. Right, so determining the second derivative. So there's just a quick example. Determine second derivative f prime prime x if fx equal 2x cubed. So first derivative f prime x, 3 times 2, 3 minus 1. So 3 times 2 gives me 6. 3 minus 1 gives me x squared. If I say second derivative, f prime prime x equal, now 2 times 6, 2 minus 1. So 6 times 2 gives me 12. 2 minus 1 gives me x to the power 1. So they have determined the second derivative. So I've just derived more than once. Now in short, the point at the second derivative is known as the point of inflection, or where cubic graph changes concavity. At this point, the graph normally changes from being concave up to concave down. As I said, a deeper explanation will be explained via drawings when we do cubic functions. So let's look at some problems. So problem number 1. Determine the interval on which f is concave up. So this still gets tested under question 8. So given f of x equal x cubed minus x squared plus 2x minus 1. They want concavity, so because it's concave up, I have to find second derivative as soon as they use the word concave. So f prime x, my first derivative, 3 times 1, which is 3. 3 minus 1, which is 2. 2 times negative 1, which becomes negative 2. 2 minus 1, which then becomes 1. 1 times 2 becomes 2, and then x falls away, and the derivative of a constant becomes 0. Second derivative, 2 times 3 gives me 6. 2 minus 1 gives me x to the power 1. 1 times negative 2 gives me negative 2, but x to the power 1, 1 minus 1, 0, then falls away. Right? Now note the a value of a cubic function, there on the top, is positive, so it's positive x cubed, therefore f then is considered concave up when the second derivative is greater than 0, and concave down when the second derivative is less than 0. Very important. Now the next one I'm going to do where the cubic function is negative. So therefore I want concave up, so I'm going to write 6x minus 2 greater than 0, because they said concave up. So you see concave up, my second derivative there greater than 0. So if I take 2 across, comes positive 2, and divide by 6, 2 over 6, so x greater than 2 over 6. If I simplify, 2 goes in itself once, 2 goes in 6, 3 times, so therefore x greater than a third will ensure that the graph or the interval allows the graph then to become concave up. Let's look at the next problem. Determine the interval on which f is concave up. So given y equal negative 3x cubed minus 4x plus 5. See the a value there is given as negative 3. The previous one, the a value was positive 1. Right, now because they've given y, I'm going to differentiate y with respect to x. 3 times negative 3 gives me negative 9. 3 minus 1 gives me 2. 1 times negative 4 would give me negative 4. 1 minus 1 is 0, and x to the power 0 is 1. So 1 times negative 4 stays negative 4. Derivative of a constant falls away. Now I'm going to differentiate a second time. Differentiate y with respect to x, second derivative. 2 times negative 9 gives me negative 18. 2 minus 1 gives me 1. And the constant there simply becomes 0, so that falls away. So as I said, the a value there is negative. Therefore, for it to be concave up now, it swaps around. The second derivative must be less than 0. So from here, minus 18x less than 0. But now take note, although I have 0 there, I'm dividing by negative. So 0 divided by negative 18, the inequality sign must change. So if the inequality sign changes, that reads x greater than 0. So if x is greater than 0, the graph would then become concave up. Right, and let's look at the last problem. So they just say determine double second derivative of x if f of x equal fourth root of x to the power 6. So we assume, you still remember how to write, I mustn't use the word assume, bad word, right? But the exponent inside goes on top and the exponent outside goes to the bottom. So that becomes 6 over 4. Alright, so 6 over 4 is the same as saying 3 over 2. 2 goes in 6 3 times, 2 goes in 4 2 times. So 6 over 4 times 1 gives me 6 over 4, or simplified 3 over 2. And there's 6 over 4 minus 1, which then gives me 3 over 2x to the power half. Second derivative, now it will become half times 3 over 2, and then x half minus 1. So 3 times 1 is 3, 2 times 2 gives me 4. Half minus 1 then gives me negative half. So my second derivative, 3 over 4, x negative half. So hope you follow, hope you enjoy the lesson. Any questions, post them in the comments. Right? Wish you nothing but the best. Bye. Like, share, and subscribe, please.